Hello everybody, this is Sif Habashi. This limit I consider the most important limit probably in all of mathematics or in all of engineering, because you'll see why. But there is a big problem when people deal with this limit. When you ask somebody who is into mathematics of some way, studying high school or first year in college or whatever, when you ask him what is the answer to this limit, he tells you it is 1. And you ask him why, he says, apply L'Hopital's rule. And this is a crime, by the way. And he says, okay, the derivative of sine x is cosine x, and the derivative of x is 1. The limit as x goes to 0 for cosine of x is 1, hence the answer is 1, and we got the right answer, then it works. But the problem is, how did you know that the derivative of sine x is cosine x? Well, he would say it is written in the textbook. Where did the textbook get it from? If he is good enough, he would say, we'll go to the original definition of the derivative. The derivative of sine x, by the original definition, is defined as the limit as h approach 0 of sine x plus h minus sine x divided by h, right? So we expand this sine x, so it is equal to the limit as h goes to 0 of sine x cosine h, put a bracket, because if you don't put a bracket, it may get confused with cosine, whatever, plus cosine x sine h minus sine x divided by h, which means the limit, which is equal to the limit as h goes to 0 of, take sine x as a common factor, you get cosine h minus 1 divided by h times sine of x, right? Plus cosine x times sine h over h. Look at this. The only way to know that the derivative of sine x, to get the derivative of sine x, whatever the derivative is, to evaluate this limit. And the only way of evaluating this limit, or the most famous way, is by getting here. And you have to know this limit, and to know this limit, you have and need to know that this limit is 0, and this limit is 1. Focus. To be able to find the derivative of sine x, you need to know that this limit is equal to 1. So this is what makes the derivative of sine x cosine x. And also this guy is equal to 0. Never mind about this guy for now. So, for example, if we thought that the limit as x approached 0 of sine x divided by x is equal to 2, for example, and we substitute 2 here, the derivative of sine x would be 2 cosine x. So when we apply L'Hopital's rule, we get that the derivative of sine x is 2 cosine x, so this limit gets 2, You get what I mean? You have to know that this limit is 1 to know that the derivative of sine x is cosine x. So you cannot use the result that the derivative of sine x is cosine x to evaluate this limit, because the result that the derivative of sine x is cosine x depends on making this value 1. You see what I mean? I like to make an analogy like there is milk and there is cow. You can get the milk from the cow, but you cannot get the cow from the milk. This is the cow and this is the milk, right? You can get the milk from the cow, but you cannot get the cow from the milk. You see what I mean? That's why you cannot prove that the limit as x approaches 0 of sine x divided by x is equal to 1 by applying L'Hopital's rule. That's a crime, mathematically. It gives the right answer, but it's not logically correct. It's called circular reasoning. So, how do we know that the limit as x approaches 0 of sine x divided by x is equal to 1? You remember what I said before? Whatever sine or cosine exists, there exists a unit circle. Let's draw a unit circle. Very perfect. Ah, damn it. Cool. I like it. Let's say this is a unit circle and this is some angle. Okay? So, this radius is 1, and this radius is 1. This height, if this angle is theta, then this height is defined to be 1 sine theta, which is sine theta, and this arc length is equal to 1 times theta, which is theta. Okay? Also, if we get a tangent from here, a vertical tangent to the circle, this is x equal to 1, and complete this radius here, this is a right angle triangle, and tangent of theta is opposite of adjacent, so this length is tan theta. That's why it is called tan or tangent of theta. You see what I mean? If you don't know, then you already knew. So, look at this. What happens as we decrease theta? If we decrease theta like this, we see that this arc length decreased. Also, this height, which is the new sine theta, decreased. So never mind about this whole one. We decrease theta. Okay, everything is alright. So this height is sine theta, and this height is tangent theta. So the arc length is theta. So the question that this limit is asking, geometrically on the unit circle here, is that what is the ratio of the length of this arc to the length of this height as theta gets closer and closer to 0? You can see that it is equal to 1 physically, because as the arc length gets smaller and smaller, this arc gets closer and closer to being a straight line. So, and this point moves to the right to being at this point. So they are getting closer and closer to each other. That's why it is equal to 1, but this is not a rigorous proof. The proof is, well, we know that this arc length is smaller than this height, tangent of theta. So theta is smaller than tangent of theta, and at the same time it is greater than sine of theta, because this is an arc and this is a straight line, and always an arc is longer than the straight line because these points are too close to each other. So this is what makes this arc longer than sine theta. So theta, which is the arc length, is longer than this height, which is sine theta. So dividing by sine theta on all of this, you know, sine theta is a positive number because theta is small. So sine theta is a positive number, so we can divide safely and the inequality holds. So this would be 1 and this is theta divided by sine theta, and this is 1 over cosine theta, because tan theta is sine theta divided by cosine theta. So if we flip everything, we can swap the 1 and cosine theta if we take the reciprocal. So cosine theta is smaller than sine theta divided by theta, and at the same time smaller than 1. Here we take the limit as theta goes to 0. You see, the limit as theta goes to 0 of cosine theta is 1. So sine theta, as theta gets closer and closer to 0, is between 1 and 1. Hence, sine of theta divided by theta as theta goes to 0 is equal to 1 by what we call the squeeze theorem. So this is a rigorous proof from the unit circle, and you cannot use L'Hopital's rule here because, as we said, the idea of circular reasoning. I hope you like this video and find it helpful, because I really hate it when some people use L'Hopital's rule with this limit in front of me, and I get angry and deal with them harshly. So don't do that, okay? When you want to prove this limit, use the unit circle and the squeeze theorem. Do not use L'Hopital's rule. Remember, do not use L'Hopital's rule with this limit. Goodbye.